Alright, let's finish strong with this problem here. Now, notice the title of problem number 4. Checking for extraneous solutions. Extraneous. What that means is that sometimes when we solve an when we solve a problem algebraically, because of the algebraic moves that we performed from on one side of the equal sign and the other, sometimes that might create a situation for ourselves that present solutions that actually do not solve the original problem. What we call those in the math biz in college, sometimes we call these irreversible steps. Most of the work that you guys do in high school math and the stuff that you guys are trained to be experts at that get you into college are being experts at reversible steps. Sometimes, occasionally, there are such things as irreversible steps, and we're going to be looking at those and how irreversible steps can sometimes create extraneous solutions. So it'd be a shame for us to have this whole title of extraneous solutions and not have an extraneous solution somewhere. So how do we find them? Well, if you look at this problem, it looks almost no different from all the previous problems we've done. And your steps at solving this are no different. You need to isolate where the radical is, or possibly a rational exponent. In this case, there are no rational exponents. It is just a square root of x plus 7. So we need to isolate that guy first. So you see what's wrong with this picture is we have the subtraction of 5 there. So we need to add that 5 and put it on the other side. Okay, so we added that 5. Do you notice something that does make this problem a little bit different from the rest of those? Wink, wink, nudge, nudge. Do you notice that this problem is actually the only problem that we've seen so far where actually the variable that we are trying to solve for is in two different spots? And in one spot, let me grab a highlighter. In one spot, we have the variable exactly in the same place as all the other problems, which is either underneath the square root or if we look over here, see how the x is still inside that rational exponent. That's all those problems have ever been. And do you notice that when we check our answers, both the answers, if there were multiple answers, they worked out okay. Do you notice that this is the first kind of problem where we actually have there's an x right there that actually is not inside the radical or outside a rational exponent. Stroke that long imaginary beard of yours and get those gears going. Something must be up here. And yes, that is a nice clue. A big clue. Like a Blue's Clues clue. Where there's a blue paw print somewhere here. It's saying that, yeah, you're probably going to get some extraneous solutions going on here when you have x in two different spots and one is inside a radical and one is outside the radical. Okay? That's a big clue there. So capitalize on that when you see it. Okay, so back at the work here. So notice the first step here is that they did the adding of the 5 to both sides. Now this is where you got to really go back to your Unit 4 work. We need to take x plus 5 squared. Remember, x plus 5 squared, wasn't that no different than us saying this, x plus 5 times a second x plus 5? And so is that a whole lot of first, outer, inner, last? Does it make sense why there is a 10x in the middle right there and not just simply x squared plus 25? Okay? Because we have the first, outer, inner, last on all that problem, on those problems right there. Capiche? So now that we're looking at this statement here, and remember, hey, look what happened over on the left. I kind of neglected to talk about that. The square root of x plus 7 squared. Since those are inverse operations, it undoes the square root. Now we're just left with x plus 7. Now, guess what we're looking at here? Yes, we are looking at a quadratic problem. And when you're trying to solve a quadratic, doesn't it make sense to set the equation equal to 0? Because if we set the equation equal to 0, we have a lot of things at our disposal. Notice in this case, they decided to factor. They could think of two numbers whose product is 18 and their sum is 9. Could they have done the quadratic formula on this problem? You betcha they could have. Okay? That would not have been a problem whatsoever. But they decided to do the factoring here, which is what they did. Zero product property allows them to say, hey, wait a minute. If x plus 3 times x plus 6 equals 0, then either x plus 3 could be 0, which subtracting 3 from both sides gives us one answer of x equals negative 3. And then we can get a second answer of x equals negative 6. Now, what was the title again here? Extraneous solutions. So maybe one of these doesn't work. So take a look at what they did right here. When they tried the negative 3, A negative 3 plus the 7 gives us the 4, and the square root of 4 would be 2. 2 minus 5 gives us negative 3, which indeed matches the solution. Remember, see how there was an x floating out here that wasn't underneath the square root? Didn't we have to substitute that negative 3 right in there for that x as well? So this answer does work. Notice we aren't putting a negative 3 in here this time with this guy. Now we need to put in a negative 6. Right? So if we put a negative 6 in there, negative 6 plus 7 would be 1. Square root of 1 would be 1. 1 minus 5 gives us negative 4. Wait, negative 4 is not equal to negative 6. So what you would do in these problems, and what I expect you to do on these problems, is to eliminate this, because that is an extraneous solution. So the only answer that we actually have here that actually works is negative 3. That's it. Okay, 3 is the only answer that works. Alright, so now it's our turn. Let's take a look at this problem. Let's check for some extraneous solutions. Okay, we'll pause it for a little bit and give you a chance to do that first step, which I think at this point hopefully you know what that first step is. Alright, so first step right there, you got it. We got to isolate that radical. In this case, the radical is at square root of 5x minus 1. So the first move that we should do here, let's add 3. I'm sorry, not add 3, but subtract 3 from both sides. When we subtract 3 from both sides, now we have the square root of 5x minus 1 should be equal to x minus 3. Now that we have isolated that square root, now it's time to square both sides. Okay? So when we square both sides, remember squaring this guy over here would just undo the square root. So now we're left with 5x minus 1. Now I have to square x minus 3. So shouldn't that give us x squared minus 6x plus 9? Okay? Kind of running out of room here. So all I'm going to do right now is I'm going to take this, 5x minus 1 equals x squared minus 6x plus 9. I'm just going to move it over here. Okay, so it's identical. Now, we have a quadratic. Your next move when you have a quadratic, got to set it equal to 0, right? So the two steps that we are going to do here is let's go ahead and let's subtract 5x from both sides. And then in one quick deft move, let's add 1. Let's add 1 to that positive 9 there as well. So when we do that, take a look at what we get. There we have it. Subtracting that 5 from that negative 6 gives us negative 11. And then adding 1 to that 9 gives us the 10. Now that we have the equation set equal to 0, I think we can factor this. I can come up with two numbers whose product is positive 10. Their sum's negative 11. I think that's a negative 10 and a negative 1, right? So we can factor that. We'll set them both equal to 0 and solve, right? So x minus 10 could be equal to 0, and x minus 1 could be equal to 0. So that means we have two possible answers here, 10 and 1. But what have we learned here? We'd better make sure we check for extraneous solutions. So let's make sure that we do that. Okay? So now here comes our check for those extraneous solutions. So 1 in the first solution, let's check 10. Let's see if 10 is legit. Okay? So when we put our 10 back into, what's this? Where's that coming from? Remember, that's coming from this guy right over here. Okay? Square root of 5x minus 1, and then add 3 and see if it's equal to x. In this case, we want to see if it's equal to x. In this case, it's 10, right? So first move, don't we have to do the 5 times the 10 because it's underneath the radical? So that would give us 50 minus 1. We still have to do 50 minus 1, which would give us the 49. And by the way, this is the square root of 49 plus 3 equals 10. This is looking promising. Square root of 49, wouldn't that be 7? 7 plus 3, 10. Yay! And there was much rejoicing. Okay? So that answer is okay. We can keep it. Let's take a look now at the other solution here. 1. Got a bad feeling about this. Star Wars. Okay? So let's take a look. Plug in the 1 the same way. But remember, we aren't putting a 10 here because that other side of that equal sign just says x. A lot of students get really confused about that. Remember, I'm putting a 1 right there because, quite frankly, the equation's telling me to put 1 right there. Because if my solution's 1, I have to put it in here next to the 5 and also right there on the other side of the equal sign. So, first step, 5 times 1, yes, that gives us the 5. Ooh, I did the other move there too. So 5 minus 1 gives us the 4. Take the square root of 4, which would be a 2. 2 plus 3 is equal to, wait a second, it's not equal to 1. That is false. You are a liar, sir. It's like ripping off a fake mustache off a guy. Okay? You are an imposter. And so then, since that's false, what that means is that we have, hey, you x equals -1, you and your fake mustache, you're an extraneous solution. Ah, you caught me, as he starts to twiddle that mustache. That handlebar mustache. It's got to be a handlebar mustache. Okay? Maybe something that looks like this. Nah, curses. How'd you know it was me? Nah. Alright, gotcha, you extraneous solution, you. So now what we can do is go over to this guy right here and say, sorry, you are not a correct solution, and the only solution that actually works here is 10. Okay? So, watch out for those extraneous solutions when you're trying to solve those problems. Okay? Good luck on 6-5.